So I've come all the way from the city of joy to the Silicon Valley of India, or the beer capital of the country. Whichever way you want to call it, I'm happy both ways. I have a very interesting topic to discuss. As she mentioned, it's called confidential computing. Now, what is confidential computing? A lot of us have heard about compute. We all know that compute today is moving from one stage to the other, from on-prem to public to edge. This we all hear. Now let's shift from compute to the security side of things. If you look at IT security, we all know how much scary it might sound, but it's a big business, right? It's about a couple of billion, hundreds of billions of dollars, and growing at more than 20-25% a year, okay? How much scary that sounds, but that's the truth. Let's move to the third scheme of things, which is data. Data is the new oil, data is what we survive for, etc., etc. And if you look at the statistics, I have got some statistics here which says that the amount of data that we produce and consume is growing at more than 25%. We are looking at not gigabytes or petabytes, but we are looking at zettabytes of data today. So if you look at the three parts, compute, security, and the data, I think if you draw a triangle around that, what's at the center of the triangle, to me, is confidential computing. But let's look deeper into it. Now, when we look at any topic, the first thing that we do is we Google it up. I did that too. And what Google says is, confidential computing offers hardware-based security solution designed to help protect data in use via unique application isolation technology. Does it make sense to all of us? Possibly yes, possibly no. Therefore, we have an eminent set of panels, and they are going to talk about it. So in the next 35-40 minutes, I'm sure we'll have a great discussion around this topic. And since the center point of this entire topic is compute, so let's first start with the largest chip maker of the world, Intel. Sangeeta, my first question to you, what is confidential computing? Can you demystify it for us from the perspective of compute, data, and security? How does it differ from the traditional techniques?
Thank you, Saurav.
Yeah.
Thank you, Saurav, for the opportunity. And yes, happy to answer the question that you have for all of us. And I'll try and break it into two parts and give you my thoughts around confidential computing. So let me start by giving a view of the opportunities that we have. And I'm sure everyone sitting in this room will agree that the opportunities to digital transformation are abound. And if we have to just kind of call a few of them, it could be, cloud economics and scale. It could be multi-party collaboration around new data. It could be blockchain-based services, and so on and so forth, okay? But with these opportunities, what we see is there are also growing customer challenges. And we have often heard that projects have been blocked, largely because of data privacy or compliance concerns. Or maybe we have heard of cloud migrations being stalled, again because of data control or sovereignty concerns. And the last one is often what we hear is, the security concerns, which is because of, persistent, sophisticated threat to data and software IP. So largely, if we see and try to understand the spectrum, what we've understood is these customer challenges led to confidential computing being invented. Okay, so that's the first part of how I would try to bring in the opportunities and the challenges that drove to get confidential computing. But if I move to the second part, I'm sure again all of us would agree that technology has developed over a period of time to protect data and to ease some of these security, privacy, or compliance concerns, but there was always a gap. And let me try to break it a bit in a simplified way. So we have often heard about data at rest. So the storage or the disk encryption, that developed and evolved over a period of time to protect data at rest. Then came in the network encryption, so that is strong, or rather getting even stronger these days to protect data in transit. But none of these did help us to protect data while it was actively in use in the processor or in the memory. And if you move the vulnerability was like if you move away from storage or you move off the network, the vulnerability still existed. And this is the gap in the data protection continuum that confidential computing is designed to address and give you a protection to your data end to end. That's how I would describe as confidential computing being designed, Saurav.
Thank you, Sangeeta. So what I pick up is cloud economics, and what I also pick up is how you describe the in-memory security aspect of it. Fantastic. So now let's move to a global tech company which helps transform lives with extraordinary capabilities. From hybrid cloud to high-performance computing. We are talking of none other than Dell. Xavier, let me go to you and ask the same question. Can you demystify cloud confidential computing for us?
Thanks, Saurabh. And I want to take a slightly broader perspective on it, right? And what Sangeeta said is extremely important. It is important to be able to secure data that is currently being worked on in memory. But confidential computing or securing the platform is a much bigger play by itself, right? Secure use SGX or features that make sure that memory is secure. You have to have other security things, items as well. For example, a silicon root of trust that guarantees that everything that goes onto a system is secure and signed. That's on a platform. When you go out of the platform, there's a whole bunch of other things that come up. Perimeter security. I think NIST called it zero trust framework, and there's a lot more that comes along with that. It's about finding the ways to make sure that data and cycles are secure across the entire range. Securing it at rest today is actually quite easy. Encrypting and securing the wire, technologies exist. Securing the platform is important, and more it's becoming a vector for breaches that are happening in the market. So confidential computing is about looking at this end to end and to be able to secure every point along the way.
Perfect. Very nicely put, Xavier. So now let's look at a different OEM, and they say that, edge to cloud company, they promise to transform our business by connect, protect, and analyze and acting on our data. So let's understand what is HP's position and play on confidential computing.
Thank you, Saurabh. I think Sangeeta and Xavier explained about what is confidential computing, but let me slightly take a different phase. Why it is important? Because if you look at it, we can easily relate to what we are doing today, right? Today, enterprises are moving from a digital transformation to business transformation. Digital transformation is the default today. And what are enterprises are focusing? Enterprises are focusing on trying to get intelligence from the business and to deliver a better experience and give a better convenience to the consumers to consume the product. If you look at all this, this is at a high level statement. But if you look at it for all this, what is going to be very, very critical is your data. All right? Because unless you have a data, you will not be able to drive this intelligence or experience or convenience. So today, what is happening in this world of multi-cloud, multi-path, or a digital transformation or a business transformation, data is moving outside the data center. So data is going to the edge, right? And that means today data is going from the data center to the edge, to the private cloud, or to the public cloud. So it is very, very important to protect the data. Because why it is very, very important to protect the data? Because enterprises are focusing on privacy, trust, and integrity of the data. And for this, it is not only protecting during when the data is in rest or in flight, it has to be taken care when the data is getting created, it has to be secured. When the data is getting processed, refined, and analysis is done, and to deliver an outcome, this entire process has to be secured. So like for this very simple way to put it is, like what Xavier also said, it is creating a trusted, secure environment for running your workload and also at the place where the data is getting created and processed. So this is where HP is looking at the confidential computing, and we are working towards this journey. And that's why if we call HP's vision also is edge to cloud, because the data is going to travel and everything is going to follow the data. Your workload, your compute, your IT, everything is going to follow the data.
Thank you, Gopal. I think that's very interesting. Everything's going to follow the data. So let's now look at a pocket to solutions, to cloud solutions provider, Lenovo. What's their story around confidential computing?
Yeah, thank you, Saurabh, and good afternoon, everyone. First, let me bring up the important information what organizations are dealing with. I think they are dealing with very, very sensitive information like PII. They're also dealing with financial transaction data. They're also dealing with some kind of healthcare information of the entire their employees and all those people. So as my co-panelists have alluded, I think we do have technologies and solutions which protects the data which is at rest. We protect the data which is in transit. But I think there is no proven technologies which really protect the data while it is in processing. That is where the confidential computing comes into picture. So this confidential computing is nothing but a technology where we isolate the sensitive data into a CPU secure enclaves. Let me repeat that, isolating the secure data while processing into a CPU enclave. And somebody call it as hardware TEE, and somebody calls it as secure enclave as well. So specifically, if you look at the secure enclave, it has the data which is being processed, and also the algorithms and the tools which are really processing the data in this entire secure enclave. And if I had to talk about three biggest benefits what customers will gain from the secure enclaves is, one is the data confidentiality. What it means is, while processing the data within the secured enclaves, nobody can view this data while we are processing the data. And second, we are talking about data integrity. That means no unauthorized entities will able to add, modify the data while it is in processing. And third, an important thing is the code integrity as well. While it is not only important to protect the data which is in processing, it also important to protect the code integrity as well. I mean, so that we don't have any kind of malicious kind of attackers coming in and trying to manipulate this data. That is the way I define the confidential computing. It is all about securing the data which is in process. Thank you.
Fantastic, thank you. So finally, let's move to one of the innovation companies, their innovations in networking computing. So let's try to understand what are their technological innovations in compute around this confidential computing space. Murli?
Thanks, Saurabh. Good afternoon, everyone. Okay, so just wanted to take a step back and then give a broader picture in terms of why the security is so important, and then maybe after that we can get into the layers at each level. Today the working model has been completely changed. The users are across, right? Whether they are in office or at home or the stations or the airports and so on, and they have the flexibility of work from home today because of the pandemic in nature. But how they are accessing the applications across, right? So each and every layer, security become a prominent, important piece for all the CIOs today. So keeping that in the mind, wherein Cisco has taken a complete security layer, starting from access, whichever the device that they're using, from the access up to the data center. And then, not sure if any one of you heard about Talos, where the threat engine tool that what we have across the globe, right? I mean, every malware and a threat that is happening across the globe, it's a consolidated view, and it will correlate with whatever the threats those are happened today, and then automatically put the learnings and then slice it down and then put it back to rest of the security platforms. That engine is really helping us to face any new threats. And the same technology has been brought it down under our computing servers as well, right? So in that with the Intel SGX, we are able to implement that in our compute platform. And from the management standpoint, where you have multiple platforms like Intersite and then Cisco Unified Computing Manager and so on. All these things, we have a BIOS tokens enabled. And then with that tokens, we are able to learn and then pick up the technology and then apply all the policies and then able to secure the complete environment. That's how we look at it.
Thank you. So I think we had a excellent some thoughts coming in. At least I understand that confidential computing is the thing that's coming in the future. But whenever we are talking about any of this new kind of technologies, I think we have to look from three perspectives. First is the consumer, the you and I. Second is the technology perspective, and third is the market perspective. And all the three has to be in place for the technology to be successful. So let's talk about the you and I, the consumers of it. And if you look at the Indian market, I think the three OEMs here, Dell, Lenovo, and HPE, they provide us most of the with the supplies. So let's ask them that how are they going to cater to this demand? What's their next steps? We'll start with you, Xavier.
So a couple of things that are changing, right? And as time progresses, more and more dependence is coming up on applications that are not hosted locally. And for example, your car today talks to a cellular tower that you're driving past, right? You're always connected to some service or the other. Everybody is accessing pieces of compute that are sitting in a series of data centers across the world. And you have, today, it is impossible for you to know where all you are connected to at this point of time. If you pick your phone and look at how many places your phone is currently connected to, if you're using an Android, you're connected to the Google service, your office is connected to users O365, so your email is polling. So, and your single device is accessing a whole bunch of compute. It is important for you that each of these connections is as safe as possible, because the moment you go and compromise one vector, there is the potential to compromise the entire chain. So from a consumer point of view, it is important that you look at services that are secured. From an enterprise point of view, it is important that they provide services to their consumers that are secured. And it is not just about, as I said earlier, it is not just about securing a single vector. It is about securing the entire chain, making sure that data is secure, that it doesn't leak. When that data is transferred from point A to point B, is it being secured? Is it being encrypted? Is it going on a tunnel that is secure? While it is being processed, is it being processed in an enclave which is impossible to go get into? So and while doing all of that, it is also important that there's a lot of services that sit behind backups, archivals, second copies, DR sites. All of those things as well are secure. So for a consumer, you should start insisting on services that propagate and spend the effort to make sure that your data is secure. For an enterprise, you should realize that a lot of consumers are starting to get aware of this and put the effort into making sure that data is secure. So just 2 cents on that.
Sure. Moving on to you, Gopal, your take on it?
Yeah, so I will put enterprise as the first strategy here, because users, of course, users are going to get the much more better features in the future, but enterprises should involve deeply into this thought process and then create an environment which is really secured, and they have to focus much more on security as an aspect. It is not only delivering a workload or running a workload. It is more important, like what Xavier said, it is creating that complete platform or an environment. Like in case if an enterprise wants to deliver a service, he should make sure that from where he is delivering, how he is delivering, and how he is going to isolate from the others, which is going to maybe share the same infrastructure or the same data center. For an example, like if you are going to run in a cloud, public cloud, like it can be any of the hyperscaler, and an hyperscaler is going to run services for multiple customers for multiple workloads. So it is very, very important as an enterprise, you need to ask the cloud service provider in terms of how he is going to isolate your environment from others to prevent any malpractices or entry into the hacking into the server. Similarly, when you are running on a private cloud, how you are going to secure within your network, how you are going to isolate your workload and isolate your computing platform. So this is very, very important for an enterprise to look at overall view in deploying a confidential computing or how to approach to a confidential computing. And the most important thing is each and every building block in a confidential computing environment, you need to make sure that everything is secured and everything is complementing each other. For example, from HP, so we have got the trusted security environment, which is the most, we cover about 360 degrees of the security of foreign infrastructure. We work with Intel and then complement the technology of creating a foundation block for confidential computing. So that is very, very important. It's not only on the hardware perspective, but also in terms of the application or also in terms of the attestations or the digital fingerprint. That is going to be very, very important. Going forward, you will see a lot of things where HP is also focusing on. It's creating a trusted supply chain, right from the design stage till the decommissioning stage. So, and we are already into the journey, and we created the most trusted secured servers available in the market today. So that is going to be very, very important because it is not only when you deploy in the data center, it also starts from where you design and then how we are going to decommission the product.
Thank you. Srini, your take.
Okay. I think by this time you might have got an idea saying that, okay, confidential computing is a must in the organization to provide the end-to-end security. Right from the time you created the data to the consumption, I think you need to put an end-to-end security in place. In my view, I think this confidential computing is already being used mostly by the ISV vendors. Actually, they are already adopting this confidential computing by the ISV vendors, where they're incorporating as a part of their software application framework, where they started using this secure enclaves, which I've described earlier, and start building their applications as well. And more importantly, I've also come across their enterprise organizations where they've already gone ahead and incorporating that confidential computing as a part of their overall data security thought process as well. I've seen that. And specifically in Lenovo, under our TrueScale umbrella, we have the HPC solutions where customers are already deploying this confidential computing for not only protecting all the data which is being processed, but also the key algorithms which you have built to process the data as well. They already started doing that. And specifically when you go further ahead to the edge computing platforms, in fact, we have collaborated with Intel accelerated cards, where we have built an edge computing platforms which has used the confidential computing within their ISV vendors and then started capturing the data, aggregating the data, correlating the data, and analyzing the data as well. So that way, it's already in use, but what I foresee is this confidential computing being adopted more and more aggressively because organizations cannot compromise on the security of the data. While they're taking care of data at rest, data at transit, but now they have to take care of data and processing as well. That is very, very crucial going forward.
Thank you. So now if Dell, HP, and Lenovo say they can meet the needs of the consumers, now let's look at the technology side of it. That's where the real invention and the innovation stand. So we heard about the Intel SGX. Let's understand that in a deeper way and how that helps in confidential computing. Sangeeta, why don't you tell us on that?
Yeah, so maybe I start with a bit of re-emphasizing on security once again. So what comes to my mind is security is not an aftermath after finalizing the solution architecture. It has to be weaved into the fabric of the solution. And confidential computing from Intel, what are we trying to focus? We are trying to focus on very high memory integrity solution for modern data services. And if I go back to the question, Saurav, on Intel SGX, So let me give you a view of Intel's confidential computing portfolio. And in the earlier section, my friends here on the panel did speak about 3 essential functions of confidential computing, which is isolation, encryption and control, and verification. I think we all stressed on these essential functions. So keeping that in mind, what is Intel's portfolio? So largely under 3 blocks. Intel SGX, which is the software guard extension, which focuses on application isolation, okay? The next one is Intel TDX, which is our trust domain extension. That is on virtual machine isolation. That focuses on virtual machine isolation. And the last one is Project Amber, which we again spoke as verification to be one of the essential function of confidential computing. So what is Project Amber in a quick 2-second? It is an independent trust verification services to be used in multi-cloud or hybrid cloud. Okay, so going back to Intel SGX. So Intel SGX is a unique technology that helps us to protect data while it's actively in use. And what we would also believe is, rather than isolating the sensitive data of the businesses, from analytics or AI model, all businesses who uses Intel Xeon scalable processors, can create, going back to what Xavier said, can create access restricted data enclaves, using Intel SGX. So, and when you do that, these isolated environments are helping the organization and the businesses to extract great value from the sensitive data while helping it to keep it confidential. Okay, so that's broadly what Intel SGX does. And lastly, Saurav, what I would like to say is the entire portfolio that I described coming in from Intel, this is backed by Intel's unmatched ecosystem, solution provider enabling, along with our security first development practices, and also a best-in-class, life cycle security support. So as an organization, we are committed to help protect our customers way after they have made their initial purchase of Intel-based platforms. So that, in essence, summarizes our confidential computing portfolio and also brings you, in essence, what is Intel SGX.
Thank you, Sangeeta. I think that was very insightful. So looking further in the tech innovation, we hear that Cisco is also implementing confidential computing through their platforms. Murli, you want to talk about that?
Yeah, for innovation being, across our architectures, and then data center being one of the fastest growing business for us, a lot of innovation has gone inside. I mean, we've been there in the computing business since quite some time with the, rack, blade, converse, and then the hyper conversed, computing systems. Recently, with Intel M7 server, we have launched the, UCS X as the platform. The X stands for X factor, wherein it's completely modular in nature. So which means the ability to adopt in terms of additional memory or the CPU on demand, a more memory, a more CPU or the GPU, and so on, right? So if the workload demands at that point of time, then the server is able to, the computing system is able to adopt all these changes, right? And then assign the resources. And by the way, a simple statistics is, we have launched this new platform in June, and it's about 7-8 months. I mean, we have acquired about 600 customers, new customers. And this innovation is really helping us a lot in terms of this space with all these new features.
Thank you. So I think we had a great discussion so far. I'm sure that this piece of technology holds a great future. So let's try to summarize and let's understand what's our takeaway from confidential computing. What are the capabilities of confidential computing? How it works out as a package for us? And what are really the value drivers? So let's go around the table. We'll start with you, Sangeeta, first.
Okay, so maybe Saurav, I wrap up sharing my thoughts, answering a question, why confidential computing? And this would largely be under 4 blocks. So with the first one is, with confidential computing, you can confidently migrate to the cloud knowing you're in control, even with the most sensitive and regulated data. The second one I would say is you can collaborate, you can have multi-party collaboration for beneficial, shared analysis, even while keeping the privacy and compliance. So that's the second one. The third one is, yeah, it also helps you to strengthen your compliance and data sovereignty programs, largely with technological controls. And the last one that comes to my mind is, yes, it hardens application security and IP protection. Again, mainly based on, hardware-based isolation and access controls. So that, in my mind, wraps up with the answering the question, why confidential computing? But in essence, it really helps you take control of your data in your hands. Thank you, Saurav.
Okay, that's good. I think cloud, collaboration, compliance, and security. What more can we ask for? Moving on to you, Murli. What to you are the value drivers? What should be our takeaways?
Yeah, so our value drivers are predominantly the integration with our software. The one of the key software which I wanted to call out is the Intersight. The Intersight predominantly is a SaaS platform, and then which can completely control the infrastructure of any enterprise, and which covers the computing piece and so on, right? Everything that is available. And then the key value here is the the security from end to end. What the Sangeeta has clearly called out, all the layers, and in addition to that, the access across, right? Because that is where the key success here, right? Because the users are spread across, right? I mean, unless until we take care of from end to end, up to the end user, up to the application, then there are always leakages, right? So that piece has been completely covered by our underlying technology layers.
Thank you. Now let's look at the OEMs. Xavier, Dell's take on it.
So, Saurav, there's an old saying that there are two kinds of organizations: those that have been compromised and those that don't know. Right? The one thing that you have to remember, that security cannot be an afterthought. Dell has been at this. We're at our 3rd generation of secure enterprise, and we've been putting security into our endpoint devices for a lot longer. It is not enough to just secure the perimeter. 90% of organizations spend a fair amount of money securing a perimeter. It is not enough. You have to secure the perimeter, you have to secure the platform, you have to secure the wire, and you have to secure data. After you have done all this, you have to take your crown jewels, which is your most important data, and have secondary and tertiary copies of it, and secure that as well. It's about building that larger framework of security. It's about thinking of security ground up from the at an enterprise level, and to be able to look at it in each aspect of what you do. It's not enough to just look at perimeter. You have to look at your client devices, you have to look at data, you have to look at enterprise platforms, you have to look at connectivity, and you have to look at how you even have to you look at how users are behaving. We've put together a framework of this end to end, we call it edge to core to cloud, from the endpoint devices all the way to the core, which is your data center, to the cloud service providers that you're using. And it is important to think about this every time you put together a framework.
Excellent, Xavier. So what I take away from what you explained is, so far we had 2 sets of people or companies, those who are compromised and those who don't know they are. Now with confidential computing, we might have a 3rd set who are actually not compromised.
Well, that's a point of view.
That's a point of view, yeah. Okay, so let's move on to HP. Gopal, your take?
So we need to realize that either we like it or not, the world is hybrid. So this is how the infrastructure is going to be deployed, or this is how the data center is going to be built up, or this is where you are going to drive the transformation journey. In this entire cycle, there are two most critical factors which we need to look at it is the security, how we are building the security around this, and second is how we are managing the life cycle of the data within your environment. And the most important is how we are going to share the data with your internal as well as with the external partners. So the managing the life cycle of the data is very, very important. And the most important thing is there has to be a deeper introspection in terms of how you are going to implement your security, the cyber security strategy in your organization. And the most important is how you are going to develop your skill set towards that in terms of building a strong, rigid cyber security system in your organization. And also it is very, very important, don't look at as a commodity for any compute platform or something. Look at the value at what each vendor is going to bring it to the table. And the most important factor is how each vendor is trying to build in the security features in the system to help you to build confidential computing. And the second is in terms of what kind of features is built into the platform in supporting the sustainability of the environment. So this is also going to be very, very key factor. And this is how you need to decide your IT strategy and decide your road path in terms of having a successful environment. And the most important is, like what Xavier said, each and every foundation block in your platform has to be secured. And they have to take care of the security on their own. Then you are going to have a complete foolproof solution so that enterprises are able to give a secured solution and also the users are going to get the secured access to the environment.
Okay, that's good. Thank you. And finally, coming to you, Gopal, if you can wrap it up and...
So,
Sorry, Srini, my bad. I was too engrossed in the topic.
Yeah.
So Srini, if you can tell us the value drivers and what's our takeaway.
Let's look at a different way. I think in this new era of data, let's look at the way how we are managing the data first. Okay, we have millions of devices which are generating millions of smart devices, millions of IoT devices, which is generating tons and tons of data, which needs to be again captured at the edge devices, okay, where you aggregate the data, correlate the data, and process the data as well. And similarly, that you pass it on to a centralized core infrastructure, which is your cloud, will be private, public, or hybrid cloud there. So if you look at the entire life cycle of this entire data, along with the infrastructure modernization, you need to look at security as one of the key and important parameter. It's just not important we protect the data at where it is at rest or at the transit. It is important to protect the data while processing at each and every level as well. Be it at the sensor level, or it be at the edge computing, or it be at the central location. Now, my final say to all our customers is, look at a comprehensive wave, right from the hardware confidential computing to the entire infrastructure modernization as well. Take it as a wholesale end-to-end data security part and drive that as an initiative. Because just providing the hardware confidential computing is not good enough as long as you have the application ISV vendors utilizing that and building the entire framework around that. That's my final advice to the customers. Thank you.
Fantastic. I think thank you so very much. I don't know about you all. I enjoyed having this discussion. I learned a lot of things. And definitely I'm very, very convinced that confidential computing is the way to go. We are done with the discussion. We still have 2 minutes left just in case anyone has a question. Okay, I see a couple of hands going there. Can we have...
Just a quick question on, this is an interesting technology and it's quite recent as I was looking up. I think it's a couple of years ago and surprising that you guys have got it into production so fast. My concerns are largely on the software aspects of it. How do we develop software that takes advantage of these things, especially the application software? What is, and how do you, I mean, is it the compilers that do it, or how do we ensure that what has to go into the secure enclave actually gets into there?
Who wants to answer this?
Shall I take a stab at that? So there are two ways, right? Now, if you're using a hypervisor, most hypervisors will by default enable a lot of these features, right? Especially if you look at versions that came out after about I'm going to say 18, don't hold me to 2018, don't hold me to that date. The most, when you're building an application, you will have to build that into the framework. And there are established code sets that you can, if you're building in Java, there are established code sets that you can build into the application. Is that something that is the norm in today's market? Not too many, unfortunately. Now, here's the nice part. Where, especially if you look at, and I'm assuming you're talking about technologies like SGX, right? If you're using something like that, which is software guard extensions, you're either putting it on a hypervisor or you're putting it in containers. And both the platforms that manage those containers or hypervisors, by default, will 99% of the time support it. Does that answer the question?
Let me add on to Xavier's point, actually. To utilize the secure enclaves, okay, these hypervisors have already released an API pattern, which is a pre-coded stuff, actually, which will help the ISV vendors or the application developers to use this API calls to use the secure enclaves.
Yeah, I think 2018 is when they stopped letting you not use it.
Yeah.
Yeah, I may be wrong. I may be a year off this way, that way.
For example, the hypervisors like VMware, they have already used the open application framework as well, which can start using the secure enclaves.
KVM uses it.
Yeah.
And I think right now compilers are available for the
Yeah.
geo attestation or
Absolutely.
the digital rights manager.
Yeah.
Okay, we have one more question.
Quick one to Saurav. So Saurav, I was catching up with your colleague Manish last week in Mumbai. So again, the same question on cybersecurity. For a company like Aditya Birla, whose core is not IT, but they are dependent on IT in all senses, looking at the commerce and the electronic commerce that you do. So how do you perceive cybersecurity as on date? Do you consider setting up internal wings? I understand the pattern of adopting to cybersecurity measures and things like that during envisaging a product and going through that PDLC and stuff. But are you planning to be dependent on external third parties for taking care of your cybersecurity measures? Or are you setting up your own wing internally? I mean, a company to a traditional company like yours, how do you plan it?
Okay. You want me to answer that? Okay, yeah, sure. So in a nutshell, because we are out of time now, so basically we have an entire ecosystem where we have internal resources as well as a lot of outsourced partners. And we definitely look at very, very next-gen technologies. And definitely, technologies like these are what we also look at. And in the, starting with the EDR and, every host of things that you can talk about. I mean, I'm just, in brief, I'm explaining. And then we have group-wide resources who bring in basically the people, process, and the technology. We have an entire stack around that. And that's how the group invests very heavily in cybersecurity, because we believe that that is something that is non-negotiable. So something else can wait, but security is non-negotiable, just like compliance. So in a very, very nutshell, I don't think I could answer that question.
I want to add one more thing.
Sure.
To that. There was a time when IT was a service. IT went from becoming a service to a business enabler, right? Enabler. Today, IT is a strategy. And IT should be a strategy in every organization. And strategic IT, security is a big portion of it. Strategic IT is about being able to use IT strategically in a business. And we've been talking about that quite a bit across the board. But when you start talking of IT as a strategy, security becomes the bottom layer of everything, right?
Absolutely. That sits across all applications, all infra, everything.
Yeah, traditionally, I mean, how the companies like Aditya Birla will envisage security. I understand, lock is a concern for everyone, but how do you deal with it? Whether you want to develop that lock within?
There are really established frameworks that have come out of NIST, and some of those organizations. NIST talks about there's a white paper called Zero Trust Frameworks. It's about, if you print it out, it's about that thick.
If I just
security is a framework. It is not, you cannot think of security as a piece. You cannot think of security as one place. Security is a framework. Go ahead, I'm sorry.
Yeah, no, I think as I clearly called out, I think a great question. While IT is being one of the piece, the security has become a bigger, threat for all the CIOs today, right? So, we need to pick up, threats will come everywhere, starting from the CPU onwards, right? The processor onwards, right? That is how, it is looking at. So we need to really pick up a framework which can actually do from end to end. That is from end user device up to the data center, right? If you go piece by piece, wherein end user security has been done, perimeter is done, and then my cloud network is done, and then I'll go to application, then this is where the correlation piece will come into the picture. None of these products are correlated to each other. Everything is kind of, silos in every part. So we need to really pick up a vendor who is agnostic in terms of addressing all the needs from end user to up to the application. And then the correlation, which I actually called out from Cisco at Talos, the Talos can actually give the complete intelligence across the universe, where the threats are coming, and it has got millions of tons of threats already in place. It will already correlate in terms of whether it is a already known threat or unknown threat. Right, so that is how the whole thing will happen, and then it will come to the complete end-to-end framework of the security.
What kind of blockchain adaptations are you also considering at the moment?
What kind of
blockchain adaptations, if any?
Yeah, maybe I think we can discuss this.
Of course.
Yeah, maybe we can take it offline. Yeah. Okay, thanks again.
Thank you.
And